Okay, so we're actually going to spend 3 days on this section. Today, Thursday, and Monday. And then Tuesday, you guys are going to have a quiz on sections 4.1 to 4.2. So we're going to start looking more at the laws of exponents. And first, we're going to deal with integral exponents. So an integer, remember, is a positive and negative counting numbers. You've already seen examples where you have positive exponents. So we're going to learn about what you need to do with negative exponents. We'll review the laws of exponents that you know about, and then we'll learn about some new laws of exponents. So we're going to focus on applying the exponent laws to expressions using rational numbers or variables as bases and integers as exponents. We'll see what we do when you have a negative exponent. We'll convert a power with a negative exponent to an equivalent power with a positive exponent. And then we'll look at solving some problems with integral exponents. So again, integral exponents just means the exponents are positive and negative counting numbers. That's what that means. So we'll start by matching each exponent law to its definition. So some of these you've already seen before, Brock. Some of these you've already seen before, and some of them will be new to you. Okay? So the first one is the product of powers. That's when you're multiplying two powers together with the same base. And we have seen that when that happens, you add the exponents and keep the base the same. Right? So I've matched those two together. Quotient of powers is when you have two powers that are being divided with the same base. And we've seen when that happens, you subtract the exponents and keep the base the same. So those two go together. Power of a power is where you have one exponent raised to another. When you have one exponent raised to another, that's the power of a power law. And when that happens, and we've seen this one before, you multiply the exponents and keep the base the same. So those ones go together. The next one on the list is power of a product. That's where you have a product, in this case a times b, in brackets all raised to the power m. So you can see basically you just distribute that power m to both parts of what's inside the bracket. Same thing with power of a quotient. A quotient means division, where you have a division, a rational expression raised to a power. Well, both the top and the bottom are raised to that power. You need to be to class on time, okay? You need to grab the booklet that's on the side there. Chapter 4 or Unit 2, I think it says. And you're Keaton? Correct? Keaton? Yeah. Right, so that's the power of a quotient law. And then finally, zero exponent. And you can see that the rule is that a to the power 0 equals 1. So we're going to learn that anything raised to the power 0 equals 1. You can do that on your calculator. Excuse me. Using a base as an exponent, 5 to the power 0 equals 1. You could have 1,000 to the power 0. That still equals 1. Doesn't matter how big the base is. Anything raised to the power 0 equals 1. That includes a negative base, negative 525 to the power 0. And notice I use brackets there, and we'll learn why. But I meant for everything to be raised to the power 0, so that's why I use brackets. That equals 1. Okay? Anything to the power 0 equals 1. What if I try and go x to the power 0 in my calculator? It still equals 1. So it doesn't matter what the base is. Anything to the power 0 equals 1. And we'll see a reason for that as we go through this part of the book. Okay? So those are the laws of exponents. Some you've already seen before. I think there's at least probably 3 new ones there. This one, I don't think you've seen before, at least not this year. That one, and the one dealing with 0 exponents, we haven't talked about that this year either. But the rest of them we have. Okay? And on the next page, there's a summary of all of those laws of exponents. And we use them to simplify expressions. Okay? Now the last one is a power with a negative exponent can be written as a power with a positive exponent. For example, a to the negative n is the same as 1 over a to the positive n. And it says a, the base can't be 0. Because you have a base of 0, you don't really have a number at all. Okay? Or a 1 over a to the negative n can be written as a to the positive n. So essentially what happens here, Brock, you with us? Essentially what happens here is that if the power is on the top, you move it to the bottom. And when you move something from the top to the bottom, the sign of the exponent changes. If it's on the bottom, you move it to the top. And when you do that, the sign on the exponent changes. So in the same way, you see 2 to the negative 3 is 1 over 2 cubed. Move it from the top to the bottom, and the exponent sign changes. So you might be wondering, where does the 1 come from on top? And here's where the 1 comes from on top. 2 to the negative 3 is really 1 times 2 to the negative 3. The negative 3 applies to the 2 only, so only it moves. It moves to the bottom, but the 1 stays on top, right? So that's where the 1 actually comes from. The last one there, 1 over 2 to the negative 3, it's on the bottom, move it to the top, and the exponent sign changes from negative to a positive. We're going to see that you usually use your other laws first to simplify, and then if you have a negative exponent at the end, then you turn it into a positive. Because in some cases, like this first one, you've got a positive and a negative exponent, but if we use one of the other laws first, you're going to see that we're not going to have a negative anymore. So we always deal with the other laws first, and then at the end, if we have negative exponents, then we will move it to make the exponent positive. But for question A, you're multiplying powers with the same base. Remember, the law says you add the exponents and keep the base the same. Up until now, we've always been dealing with examples where the base was a variable, a letter. But it doesn't matter if their bases are numbers. As long as they are the same base, you can apply the law. And in this case, you're multiplying powers with the same base, so you add the exponents and the base stays the same. And when you add 8 and negative 3 together, you're going to be left with positive 5 as an exponent. So there's our answer. The question says, leave it as a power with a single exponent. So we don't have to actually evaluate that. We certainly could using our calculator, but we don't have to. Right? Question B. In this case, once again, you're multiplying powers with the same base. Both of those powers have a base of 0.8. The law says that you add the exponent and you keep the base the same. So when you add the negative 2 and the negative 4 together, that'll give us an exponent of negative 6. But we can't leave it like that. We cannot leave an expression with a negative exponent. We need to make the exponent positive. Remember, this is the same as 1 times 0.8 to the power 6. So the 1 will stay on top, the 0.8 will move to the bottom, and when you do that, the exponent sign changes from a negative 6 to a positive 6. So there's our answer. We've written it as a power with a single exponent. And remember, the exponent always needs to be positive. Okay, question C. In this case, you're dividing powers with the same base. The law says that you subtract the exponents and keep the base the same. So the top exponent is 5, and from that you're going to subtract the bottom exponent, which is a negative 3. And so we have to remember what we learned about dealing with integers. Subtracting an exponent is the same as adding the opposite. Instead of subtracting a negative, you can add a positive. Or you can just remember that a minus minus always becomes a plus positive. Because subtracting a negative, you add the opposite. You add a positive. And so now, 5 plus 3 is 8. The answer becomes x to the 8. So again, we use the quotient law. And then in the end, we didn't have a negative exponent we needed to worry about. Always use the other laws first. At the end, if you still have a negative exponent, then you make it positive. Question D is similar. You're dividing powers with the same base. Both of those have a base of 2x. The law says that you subtract the exponents and keep the base the same. The base doesn't change. It stays 2x. And once again, the minus minus becomes a plus positive, so it'll be 2x to the power 3 plus 2, or 2x all to the power 5. So there's our answer. Those brackets are important. They're there in the original question. That's our base. They have to be there in the answer as well. Okay? So on the next page, it says write each expression with positive exponents. That 2 to the negative 1 is the same as 1 times 2 to the negative 1. You need to make the exponent positive, so the 2 has to move from the top to the bottom. The 1 will stay on top, the 2 will move to the bottom, and it'll become 2 to the positive 1, which you don't need to put the positive 1 there if you don't want to. It's 1/2. Question B, again, this is the same thing as 1 times 3 to the negative 2. You need to make the negative 2 exponent a positive. Right? That negative 2 exponent is on the 3, so the 3 moves. The 1 stays on top, the 3 moves to the bottom, and when you do that, the exponent sign changes from negative to positive. And I mean, you could say that's 1 over 9. 3 squared, remember, means 3 times 3. But you don't need to. It says write each expression with positive exponents. Question C. You are multiplying powers with the same base. The law says you add the exponents and keep the base the same. So that's what we show here. Add the exponents and keep the base the same. And in this case, 6 plus negative 3 is positive 3. So there's your answer. We've written it with a positive exponent. Question D. Multiplying powers with the same base. The law says you add the exponents and keep the base the same. So the base will stay 5. You don't multiply the 5s together. The base stays the same. Right? And so now we need to add the exponents. You'll get negative 8 plus 2, which is negative 6. Remember, this is the same thing as 1 times 5 to the negative 6, because we need to make the exponent positive by moving it from the top to the bottom. That exponent of negative 6 applies only to the 5. So only the 5 moves. The 1 stays on top. The answer is 1 over 5 to the positive 6. Question E. You're dividing powers with the same base. The law says you subtract the exponents and keep the base the same. So you need to subtract. Negative 5, take away 2, which is negative 7. This is the same as 1 times 6 to the negative 7. And I write the 1 there just to reinforce that technically there is a 1 in front of that, because when we move the 6 down to the bottom, we can't leave the top blank. We need something there. And that something will always be the number 1. But that's where it comes from. So it's going to be 1 over 6 to the positive 7. Right, question F. You're dividing powers with the same base. The law says you subtract the exponents and keep the base the same. And negative 2 take away 5 is negative 7. So you get 7 to the negative 7. Once again, that's the same thing as 1 times 7 to the negative 7. And we do that because we need something on the top. We cannot leave a blank there. So that power of negative 7 only applies to the base of 7, so only the 7 base moves down. And when you do that, the exponent sign changes from negative to a positive. So there's the final simplified answer. Take a minute. Look at this slide. Circle the ones that are correct, or incorrect, I should say. Circle the ones that are incorrect. So you can say I've labeled them A, B across the top, C, D across the second row, E, F across the third row. Allie, is the first one correct or incorrect? Yeah? You want to bet a pop on that? Oh, come on. It's so much fun. She says it's correct. Jan, do you agree with that? You calling her a liar? Sounds like you are. Why is that not correct? Mm-hmm. You actually multiply the exponents and keep the base the same. So that will be 4 to the negative 6, or 1 over 4 to the positive 6. So that one is definitely incorrect. What about the next one I've labeled B? Keen, is that correct or incorrect? Incorrect? What's wrong with it? Subtract the what? Pardon me? Subtract the what? Subtract the exponents and the base stays the same. So we'll have negative 2 take away negative 3. What's negative 2 take away negative 3, Keen? No. The minus minus becomes a plus positive. What's negative 2 plus 3, Keen? What's negative 2 plus 3? Negative 2 plus positive 3 is what? 1. That becomes 5 to the power 1, which is not the same as 1 over 5. If it was 5 to the negative 1, that would be the same as 1 over 5. So this one is incorrect as well. Pardon me? What about the next one? Brody, is that correct or incorrect? Yes, because you're going to square both the 1 and the 2. 1 squared is 1, 2 squared is 4. That one is correct. What about the next one, Declan? Correct or incorrect? Why? That's right. The zero rule says that 9 to the power 0, or anything to the power 0, actually equals 1. So that one is incorrect. Next one, Cherry. Why? Okay, and get what? 10 to the power. If you multiply the two exponents, what does the new exponent become? Negative 10. That's right. Then you move the 10 to the power negative 10 to the bottom so that the exponent sign becomes positive 10. So that one is correct. What about the next one, Sal? Is it correct or incorrect? Why? Well, even back up further than that, you can only use the laws of exponents if the bases are the same, and they're not. Bases aren't the same. You cannot use the laws of exponents here. It's not saying that you can't evaluate this, but to evaluate this, you'd have to square the 3, which is 9, times the square of 5 is 25. So the answer is actually 9 times 25, which is 225. That's the actual answer. You cannot use the laws of exponents here because the bases are not the same. Pardon? That's right, because you don't add the bases. Base stays the same. All right, so question says, simplify each of the following. Even though there are negatives in some of the exponents, you will not end up with negative exponents in your answers. We are simply practicing the laws of exponents with negative exponents. So for question 1, you're multiplying 3 powers all with the same base of c. So the law says you add the exponents and keep the base the same. Make sure you note that that middle c is a power of 1. That middle c is c to the power 1. So when you add the exponents, it'll be 3 plus 1 plus 2. You're going to get c to the power 6. Number 2, we have one exponent raised to another. The law says you multiply the exponents and the base stays the same. Negative 4 times negative 5 is positive 20. So there's our answer. Question 3. Everything inside the bracket is raised to the power 2 outside. So the 3 is raised to the power 2. The p to the 4th is raised to the power 2. And the q cubed is raised to the power 2. Now, I don't expect you to write it out like that, but that's exactly what's happening. You have to make sure you square everything inside the bracket, including the 3. And 3 squared, remember, means 3 times 3. It means 3 is multiplied by itself twice. That's 9, not 6. It's not 3 times 2. It's 3 multiplied by itself twice. And then for these last two parts, you have one exponent raised to another, so you multiply the exponents and keep the base the same. You multiply the exponents and keep the base the same. There's the final answer. Question 4. Each part inside the brackets raised to the power 5 outside. Once again, you'll have one exponent raised to another, so you multiply the exponents and keep the base the same. For both the top and bottom, multiply the exponents and keep the base the same. Question 5. You're going to do this in two parts, starting with the coefficients. You're going to divide the coefficients. 25 divided by 5 is 5. And then when you divide the powers, when you divide the h's, you're dividing powers with the same base. The law says, what, Brooklyn? Who? You want to bet a pop on that? Do you want to bet a pop on that? Well, I didn't say anything, so there's nothing to bet on. When you divide powers with the same base, what do you do to the exponents? You subtract them. And what happens to the base? Pardon? No, the base stays the same. So you're going to subtract 5 and negative 4. Cheney, what's 5 take away negative 4 become? 9. I didn't ask how many boyfriends you had. I wanted to know what the new exponent was. 9. Do we need to do anything else to that, Keen? Why? Because there's no negative exponents. Yeah. Question 6. Everything inside the brackets raised to the power 3 outside. And remember, when you have one exponent raised to another, you multiply the exponents and the base stays the same. So for the x to the power 3, it's 3 times 3 gives us x to the power 9. This y is y to the 1. You got to multiply that exponent by the 3. It'll become y cubed. And then for the z, multiply the exponents. 4 times 3 is 12. It becomes z to the 12th. There's your final answer. Question 7. I'm going to do this in 2 steps. The first step is multiply the 3 coefficients together. It's 2 times negative 3 times positive 1. Right? There's no number in front of the m to the negative 3, but you can always add a coefficient of 1 in front of anything. 2 times negative 3 is negative 6 times 1 stays negative 6. And now we multiply the 3 m's together. What do we have to do, Alicia? Who? We're multiplying those 3 m's together. What do we have to do? When you multiply m to the 10 times m to the negative 4 times m to the negative 3, what do we do? Okay. Stanley? What do we do to multiply those 3 m's together? Brooklyn Lorenz, can you help them? And what happens to the base? Stays the same. So you're going to add the 10, the negative 4, and also the negative 3. So that gives us negative 6m. 10 plus negative 4 is 6, and 6 plus negative 3 is positive 3. That's where I'm at right now. Am I done, Emil? Why not? What's negative? Sure. Coefficient's negative. We agree on that. Like we just became best friends right there because we agree on it. But that doesn't matter. It's only negative exponents we have to worry about, not negative coefficients. There's nothing you can do to change that negative coefficient, and you don't have to. It's only negative exponents you have to worry about. So that one is done. Question 8. Do it in 2 steps. First, divide the coefficients. 8 divided by negative 2 is negative 4. What do we do to divide the d's, Brock? Yeah, you can. We're dividing powers with the same base. What do we do to the exponents? Yeah, so you could tell me. I'm sure there's a few things you want to tell me. Some you'll get in trouble for. This one you wouldn't, though. So you're going to subtract the exponents. What happens to the base? Yeah, stays the same. So you're going to have 2 take away negative 1 when you subtract the exponents. Leaves us with what, Emery? 2 minus negative 1 is equal to, what does the minus minus become? Plus positive. So it's going to be 2 plus 3, but thank you, team, for helping Emery out. You're going to add those exponents now because the minus minus becomes a plus positive. Is it done, Emil? Yes. Negative coefficients are fine. There's nothing you can do, and you don't have to. It's only negative exponents you need to worry about. Peyton, what do we do for number 9? So what would it look like? Tell me what to write. Jan, is that right? Why not? You're supposed to multiply the exponents, right? When you have one exponent raised to another, you multiply the exponents and the base stays the same. You want another kick at it, Peyton? Come on. Okay. What's, yes, a negative times a negative is a positive 15, and then b to the power negative 2 times negative 3, positive 6. And then what's the power on c? Positive 3. Now we're done. All those exponents are positive, so we're good. Olivia, what's the answer for question 10? That's right, 1. Anything to the power 0 is 1. Now, I want to show you something. What if you write it without brackets? Like that. Ava, what do you think that answer would be? Would it be the same? Would that be 1, or is it something different? You think it's the same? What does the power 0 apply to here, the way I just wrote it? It applies only to the c, not the 5. This is the same thing as 5 times c to the 0. That's what that means. So without the brackets, the exponent 0 only applies to the c, not the 5. C to the power 0 is 1. So the answer actually to this one is 5 without the brackets. So you always have to be careful when you're dealing with zero exponent. Make sure you know what that 0 exponent applies to. And the same can be said for any exponent. Whether it's negative or a positive number, doesn't matter. Make sure you know exactly what that exponent applies to. Without the brackets, the 0 here only applies to the c, not the 5. Jensen, how's your day going? Yeah, but first I asked how your day was going. It's going okay? It's cool. It's cool. So you're loving it, is what you're saying. Right. So what do we do? So first I would divide the coefficients. 16 divided by 8 is 2. And then we'll divide the powers that have the same base. So what do you do to divide m to the 9 by m to the 5? You're dividing powers with the same base. What does the law say? What do you do to the exponents? You subtract them. And the base stays the same. So 9 take away 5 is positive 4. What will the exponent on n be, Jensen? That's right, because on the bottom, the n would be considered n to the power 1. So it's going to be 5 minus 1, which is 4. And what will the exponent on the p be, Jensen? 7 minus 5 is 2. You're done. Right? You simplified it. What about number 12, Sophia? But first, let's deal with the coefficients. Negative 2 times 4 is negative 8. So what will the power be on the variable Why? Yes, because you're adding the exponents. 5 plus -2, +3. What about the z? Because you're adding -3 and 5 together, which does give you +2. Is that one done, Riley? Yeah, because a negative coefficient is fine. And there's nothing you can do with it anyways, but you don't have to. Only negative exponents. So this next one I probably do in 2 steps. The easiest way to do this one would be to simplify inside the brackets first by dividing. Divide the powers that have the same base. Chloe, what's x to the 5th divided by x to the -2? So you're going to subtract the exponents. It'll be 5 minus -2. What does the minus minus become? Yes, it's going to be x to the 7. What will the exponent on y be? Yes, because they're both y to the 1s, and 1 minus 1 is 0. And anything to the power 0 equals what, Brock? 1. Another way of looking at it is you're dividing something by itself. That's another way of looking at it. When you divide something by itself, you get a 1 there. But that 1 will be multiplied by the x. And again, the minus minus becomes a plus positive. So it'll be x to the 7th times 1, or just x to the 7th to the power 3. And Keaton, what do you do to the 7 and the 3? You multiply. 7 times 3 is 21. There's your final answer. Number 14, again, I'll do this in a couple steps. I'll start first by simplifying inside each bracket because I've got powers with the same base on both the top and bottom. So when you divide the a here, a to the 3rd divided by a squared, you subtract the exponents and keep the base the same. 3 minus 2 is 1, so you can write a to the 1 or just a. Same thing with the b. b to the 7th divided by b to the 4. You subtract the exponents and keep the base the same. So in that first bracket, everything was squared, so that's still there. Times, in the second bracket, a to the 5th divided by a cubed. Subtract the exponents and get a squared. b to the 6th divided by b to the 1. Subtract the exponents and get b to the 5th. And that's all cubed. So this exponent that I just wrote there is a 5. So next, I've got exponents inside the bracket raised to an exponent outside. I need to multiply those exponents. A to the 1 times 2 would be a squared. B to the 3 times 2 would be b to the 6th. And that's multiplied by a to the 2 times 3, which is a to the 6th. B to the 5 times 3, which is b to the 15th. And now, finally, we're multiplying powers with the same base. So we'll add the exponents and keep the base the same. A squared times a to the 6th, you add the 2 and the 6 to get 8. Keep the base the same. When you multiply the b's together, add the exponents. Keep the base the same. 6 plus 15 is 21. There's the final simplified answer. Okay? Question 15. B cubed c to the 0 all squared. Well, what's c to the 0? That's 1. And 1 times b cubed will just be b cubed. So really you just have b cubed to the power 2, which will be b to the 6th. You multiply the exponents there and keep the base the same. Times. Everything inside this second bracket is raised to the power -1 outside, so we multiply the exponents, and you'll get b to the positive 1, c to the positive 3. And that's multiplied by bc squared. And now when we multiply the three b's together, we add the exponents. So it'll be b to the 6 plus 1 plus 1, b to the 8. And when you multiply the two c's together, again, add the exponents. 3 plus 2 is 5. You'll get c to the 5th. And even if you left that c to the 0 as c to the 0, and you multiply the 0 by 2, you'd still get c to the 0. And if you kept that till that last step, you'd be adding 0, 3, and 2 together, and you still get 5. But it's much simpler just to get rid of that c in the first bracket, because anything to the power of 0 is 1, and so it becomes b cubed times 1, which is just b cubed. Try 16 on your own, and then we'll check it. I would simplify inside the brackets first, and then deal with the power outside. So dealing inside the brackets first, when you divide the y's, you subtract the exponents. 3 take away negative 2 becomes 3 plus 2. Minus minus becomes a plus positive. So that'll be y to the 5th. When you divide the z's, 6 take away 3 is positive 3. That's all raised to the power 2 outside. And now we multiply the exponents and keep the bases the same. Y to the 10th, z to the 6th is the final answer. What's that, Keen? So on that back page is an assignment. You're going to hand this one in for marks. Okay, so this will be due tomorrow. Get it done today and you want to hand it in, that's perfectly fine. But it's getting handed in, it's counting for marks. So we're going to spend tomorrow and Monday working on all the same stuff. And then remember, Tuesday you're going to have a quiz on these first two sections. 4.1, which we did yesterday. And like I said, we're going to spend today, tomorrow, Monday on 4.2. Yes, Sal. Rip the page out. Make sure you put your name on it. Absolutely. Yeah, I don't want the whole package. Rip out the sheet. Put your name on it. If you want to take a selfie sticking your tongue out, Brooklyn. If you want to take a selfie, Brooklyn. If you want to take a selfie sticking your tongue out, then you go right ahead. Was that for me? Oh. Okay.